can't run. Too late to turn back. This is the payback. Don't act like you don't know. Know what I came for. Too late to turn back. You take one, I take one. You can't hide, you can't run. Too late to turn back. This is the payback.
Hurry up and wait.
Assalamualaikum. How are you today? Continue your last lecture on pipeline protocol. We're going to focus on go back N. What is go back N?
Go back N. Sender can have up to n unact packet in pipeline. Receiver only send cumulative act, such as doesn't act packet if there is a gap. Sender have timer for orders unact packet. When timer expired, retransmit all unact packets.
While they... See in front. Sorry. You go over there. Do you understand? Can someone wake you up? Why are you sleeping? Did you understand what I'm teaching? Do you understand class about GBN?
Yes. No, I'm not very clear about the SCK part.
Okay, I have an animation about go back N. I think it might help you to furthermore understand about go back N. Just enjoy the animation. Okay, let's proceed to the next part. That is the receiver extended FSM.
In our GBM protocol, the receiver discards out of order packets. Although it may seem silly and wasteful to discard a correctly received but out of order packet, there is some justification for doing so. Recall that the receiver must deliver data in order to the upper layer. Suppose now the packet N is expected, but packet N plus 1 arrived. Because data must be delivered in order, the receiver could buffer or save packet N plus 1 and then deliver this packet to the upper layer after it had later received and delivered packet N. However, if packet N is lost, both it and packet N plus 1 will finally be retransmitted as a result of GBN retransmission rule at the sender. Therefore, the receiver can simply discard packet N plus 1. The advantage of this approach is the simplicity of receiver buffering. The receiver need not buffer any out-of-order packets. Therefore, while the sender must maintain the upper and lower bounds of its window and the position of the next segment within this window, the only piece of information the receiver need to maintain is the sequence number of the next in-order packet. This value is held in the variable expect seg number, shown in the receiver FSM in the figure. Of course, the disadvantage of throwing away a correctly received packet is the subsequent retransmission of that packet might be lost or garbled, and thus even more retransmissions would be required.
Excuse me, can I have your attention please for one more time?
RDT send is called from above. The sender first checks to see if the window is full, that is, whether they are an outstanding unacknowledged packets. If the window is not full, a packet is created and sent, and variables are appropriately updated. If the window is full, the sender simply returns the data back to the upper layer, an implicit indication that the window is full. The upper layer will most likely then have to try again later. In a real implementation, the sender will presumably have either buffered but not immediately sent this data, or will have a synchronization mechanism, for instance a semaphore or a flag, that would allow the upper layer to call RDT send only when the window is not full. A timeout event. Our sender use only a single timer, which can be thought of as a timer for the oldest transmitted but not yet acknowledged packet. If an ACK is received but there are still additional transmitted but not yet acknowledged packets, the timer is restarted. If there are no outstanding unacknowledged packets, the timer is stopped. Izati. No, Izati.
She's into superstitions, black cats and voodoo dolls. I feel a premonition, that girl's gonna make me fall. She's into new sensations, new